Hi everyone, so welcome back to my channel Mathematicals Swati 3226. So here I am with my another video, and that is exercise 3.3 topic matrices class 12 NCERT solutions. So yes, without further delay, without further wasting any time, let's get started with the video because we have a lot of questions to do. Okay. One thing I want to remind you that if you're watching my channel for the very first time and if you have not subscribed to my channel, please subscribe and support me. Okay, so now let's start with the solution. And the first question is, find the transpose of each of the following matrices. Let me tell you that exercise 3.1 and 3.2 I have already covered. So I'm going to put the link of both these exercises in the description box. So make sure you watch those two videos first and then you come back to here. Okay, so let's start with the video. And the first one is find the transpose of a matrix. Let me tell you the transpose. What is the meaning of transpose of a matrix? Transpose is simply that whatever matrix is given, you just need to make the row in column and column row. That is it. For example, in the first one, suppose this A is 5, 1 by 2 and minus 1. How many rows we have? We have 3 rows. How many columns we have? Only one column, right? Now, we need to find out the transpose of this, correct? So what are we going to do? We will just change this. This is a column matrix, okay? Remember what is a column matrix? A matrix which has one column, okay? That is called a column matrix. So we will make it a row matrix by just changing it to 5, 1 by 2 and minus 1. That is it. This is the answer. We also write down the transpose of a matrix as A raised to the T. T here is the transpose. Let's move to the next one. So imagine this is a matrix B. So we have to find out the transpose of B, right? So here you can see that this is your first column. First column, what are the entries? 1 and 2. So if you find the B transpose, the first column will become first row. So let's do that here. 1 and then 2. Second column, that is minus 1 and 3, that will become the second row. And that is minus 1 here and 3 here. This is the B transpose. Now let's find out the last question of the first one. Or the last sub question you can say. This is imagine C. Okay. So we have to find out the transpose of the matrix C. So we are simply going to write down that C transpose is first C. It's not always like I'm saying that first column, I'm making first row. If you want, you can also say it vice versa. First row, I'm making first column. Okay, whatever you want to say. So I'm just saying here that first column, I'm making it first row. So minus 1, 2, 3, and 2. Second column, I'll make it as second row. So this will become 5, 5, 3. Third column, I'll make it as a third row. So this is 6, 6, minus 1. And this is the C transpose. And we are done with the first question. It was very straightforward. Now let's come to the question number 2. You can see that we have two matrices given of order 3 by 3. Now all these basic things like how to see the order, how to check what is the order of the matrix, everything I have already covered in my previous video. So make sure again you watch that video. So we have a matrix A given, we have a matrix B given, we have to verify A plus B. Okay, this is also a symbol of transpose only. Remember, either we denote the transpose as this or we denote it as this. Both are same. Okay, so it's a proof, right? So let's start with the LHS. So on the LHS, on the left hand side, what do we have? We have A plus B transpose. First, let's find out A plus B. That means the addition of two matrices. And that also I had covered very, very properly in my first and the second video. First video only. So yes, please watch that video. A plus B. That means this entry plus this entry. So minus 1 plus minus 4, that is going to be minus 5. 2 plus 1, that is 3. 3 plus minus into minus is minus. So it is actually 3 minus 5 and that is minus 2. Next we have 5 plus 1, that is 6. Next we have 7 plus 2, that is 9. Next we have 9 plus 0, that is 9. Next we have minus 2 plus 1, that is minus 1. Next we have 1 plus 3, that is 4. And next we have 1 plus 1, that is 2. corresponding entries, just get added. That is it. This is our A plus B. But what do we have to find? We have to find A plus B transpose. Okay, this is also simple, as I said. So it's very simple. The first column will become first row. So -5. See, this is the first column. The first column, right? That means these entries. That will become the first row. -5, 6, -1. Second column, that is 3, 9, 4. Second row. Third column, that will become third row. -2, 9, and +2. This is what we have for A plus B transpose. That means we have found already the value of LHS. Now let's find out the value of RHS. Okay. So RHS, we have A transpose. So first we need to find out the value of A transpose. So let's find out what will be A transpose. So simply A transpose, first column will become first row. So -1, 5, -2. Second column will become second row. So 2, 7, 1. Third column will become the third row. So 3, 9, 1. This is our A transpose. Now we have to find out B transpose as well. Then we will add it. So B transpose, again, first column will become first row. So -4, 1, 1. Second column will become second row. So 1, 2, 3. And third column will become third row. That is -5, 0, 1. So we have A transpose, we have B transpose. But on the RHS, we have to find out A transpose plus B transpose. So we simply have to add them. Okay. So let's add it. Corresponding entries will get added. So -1 plus -4, that is going to be -1 -4, that is -5 only. Next is 5 plus 1, that is 6. Next is -2 plus 1, that is -1. Next is this 2 plus 1, that is 3. Next is 7 plus 2, that is 9. Next is 1 plus 3, that is 4. And next is 3 minus 5, that is -2. 9 plus 0 is 9. 1 plus 1 is 2. Now, this is our RHS. Now, you can see that we got this as LHS. Okay. And we got this as RHS. Can you just do one thing for me? Can you just check that do we have the entries proper? Yes, exactly the same matrix. -5, 6, -1, 3, 9, 4, -2, 9, 2, and here the same. And also, if you want, you can write down the order here, because we write down here the order of the matrix. 3 cross 3, 3 cross 3. And of course, we have proved that LHS is equal to RHS. Hence proved. Now let's go to the second question, where we have to find out A minus B, like we have to prove A minus B whole transpose is equal to A transpose minus B transpose, right? So for that, what we will do, we will directly find out first A minus B, and then we will find out the transpose, okay? So I'll do it here and do one thing. I'll take this question and I'll just draw it. I'll solve it on the other side. So let me draw this. Sorry, let me erase this and let me take a picture, and then we will solve it on the other side. So first one is already proved. Now it's about the second one. Let's go on the side and let's do it here. Okay. It's too small, but okay, I'll make it bigger. So on the LHS, what I have? On the LHS, I have A minus B transpose, right? First find out A minus B. So if you want to find out A minus B, what is the value of A minus B? A minus B is simply going to be, all the entries are going to be subtracted. It's as simple as that. So -1 minus, I'll just write down here. -1 minus -4. If you simplify this, -1 minus into minus is plus. So -1 plus 4 is 3. So it is 3. Next we have 2 plus 1, that is 3. Oh, sorry, it's 2 minus 1. I'm extremely sorry. We are subtracting it. Yes. So -1 minus -4, that is 3. 2 minus 1, that is 1. 3 minus -5, that is 3 plus 5, and that is 8. Next, we have 5 minus 1, that is 4. 7 minus 2, 5. 9 minus 0, 9. Minus 2 minus 1, that is -3. 1 minus 3 minus 2. 1 minus 1 is 0. This is A minus B, but we need to find out A minus B transpose. So you know how to find out A minus B transpose? First column will become first row, so 3, 4 minus 3. Second column will become second row, so 1, 5 minus 2. And third column will become third row. So it is 8, 9, 0. This is what we have on the left hand side. Okay. Now let's figure out what do we have on the what we'll get on the right hand side. For that, we need to find out A transpose minus B transpose, right? We'd already found A transpose and B transpose on the other side. So we can quickly find out A transpose minus B transpose here, right? So A transpose minus B transpose. I'll just bring your attention to this A transpose and B transpose, right? So we have to subtract it. So that means minus 1 minus minus 4. That is going to be minus 1 plus 4, and that is going to be 3. So the first entry is 3. Next is 5 minus 1, that is 4. Next is minus 2 minus 1, that is minus 3. Next we have 2 minus, okay, so what is that? It's, let me check, 2 minus 1, right? It is 2 minus 1. So 2 minus 1 is 1. Next we have 7 minus 2, that is 5. Next we have 1 minus 3, that is minus 2. Next we have 3 minus minus 5, that is going to be 8. Next we have 9 minus 0, that is 9. And then we have 1 minus 1, that is 0. This is our RHS. Now again, if I bring your attention to the LHS and to the RHS, you can see we have got the same matrix, right? Again, if you want to write on the order, we can write on the order 3 by 3 and 3 by 3. And because LHS is equal to RHS, hence 2. And we are done with our first question of exercise 3.3. Now it's time to go to the next question. So for that, let's start with the next question, which is here. It's very small. I'll make it bigger, but you can just see the question properly. And let's start with the, okay, this is the sixth question. Please, I have another question over here. Yes. Okay, so we are done with the first and second question, right? So we will start with the third question. Correct. Okay. So the third question is again exactly similar to what we did in the second question, right? So let's start with the third one. It's again very simple. So third question, first one, right? So let me just decrease the width here. Okay. So you can see we have a matrix A given, we have a matrix B given, right? The order of A is going to be how many rows? 3 rows. How many columns? 2 columns, so 3 by 2. And the order of B is going to be how many rows? 2 rows. And how many columns? 3 columns. So 2 by 3, right? Now we need to verify the following. So first one is on the LHS, we have A plus B transpose. So first, we need to add A and B, right? But here I want to tell you something, that if you look at this A plus B, you are simply going to, yes, there is one thing I want you to notice, that here it is A transpose given, right? It is not A. From this A transpose, we will find out A first, and then we will verify this LHS and RHS. So let me tell you one formula about a transpose, that if you have a transpose given, okay, transpose matrix given, and then if you find out the transpose again, that means it's like a transpose of transpose, you will get your original matrix. That is it. This is a formula. Okay, so let's find out A by doing A transpose, and that is simply going to be, because it is already A transpose, so if you find the transpose of this, the first column will become first row, that means 3 minus 1, 0, and second column will become second row, that is 4, 2, 1. Now this is your A and this is already your B, right? What do we have to find? We have to find first A plus B, and then we'll find out A plus B transpose. So A plus B is simply going to be 3 plus minus 1. What is that? It is 2. Minus 1 plus 2, that is going to be 1. 0 plus 1, that is going to be 1. 4 plus 1, that is going to be 5. 2 plus 2, 4. And 1 plus 3, 4. So this is our A plus B. But we need to find out A plus B transpose. So what is that? You will make the first column first row. So 2, 5. Second column second row. So 1, 4. And third column third row again 1, 4. This is our A plus B transpose. Now we have to find out A transpose plus B transpose, right? So for that, I'll just make it a little smaller so that I can solve it. Okay. So on the RHS, we need to find out A transpose plus B transpose. So what is A transpose? A transpose is already given. B transpose we need to find out, right? Because we have not given B transpose, we have given B only. So if you want to find out B transpose, the first column will become first row. So minus 1, 1. Second column will become second row. So 2, 2. And third column will become the third row. That is 1, 3. So this is our B transpose, right? We need to check A transpose plus B transpose, right? So if you add this is A transpose here. Let me change the color. This is A transpose here and this is B transpose. We need to add them. So add the corresponding entries. 3 plus minus 1, that is 2. Next 4 plus 1, that is 5. Next minus 1 plus 2, that is 1. Next 2 plus 2, that is 4. 0 plus 1, that is 1. And 1 plus 3, that is 4. So this is our RHS. And you can clearly see that LHS is equal to RHS. Hence, proved. You can write down hence proved. Now the same thing we will do for the second one as well, right? So in the second one, we have to first find out A minus B, right? So it's A minus B, right? Where is A? Here is A. Where is B? Here is B. So it's A minus B, right? So let's check. Let's take this and then minus B. So 3 minus minus 1, that is 4. Minus 1 minus 2, that is minus 3. 0 minus 1, that is minus 1. 4 minus 1, that is 3. 2 minus 2, that is 0. 1 minus 3, that is minus 2. So this is our A minus B. But we have to find out A minus B transpose. So what will be A minus B transpose? It will simply become first column will become first row. So 4, 3, minus 3, 0, minus 1, minus 2. So this is our RHS. Sorry, LHS. Now we will find out RHS. So for RHS, you can see we have A transpose minus B transpose. A transpose we already have, which is here. Let me raise these arrows so that you can understand. What am I saying? Okay. So you can see that A transpose is here already and B transpose we have found here. We simply have to find out A transpose minus B transpose. So let's do that. 3 minus minus 1, that is 4. Next is 4 minus 1, that is 3. Next is minus 1 minus 2, that is minus 3. Next is 2 minus 2, that is 0. Next is 0 minus 1, that is minus 1. And next we have 1 minus 3, that is minus 2. And you can clearly see that we have the same LHS and the same RHS. That is why we can say that hence proved. All right, so we have proved this. Now let's go to the fourth question. So I'll just go on the side to do this fourth question and the fifth question. So yes, let's go on the other side. All right, we have enough space here and there. Okay, so let's start with the fourth one. In the fourth one, we need to find A plus twice of B whole transpose, right? So let's start with the fourth solution. You have A transpose given in the question, right? So first we'll find out the value of A by using the formula A transpose transpose. A transpose is already given here. If you find out the transpose of this again, you will get the first column, that is minus 2, 1 will become the first row. So minus 2, 1 here. Second column will become the second row. So 3, 2 here. That is the value of A. Now we have to find out twice of B, right? Because we have A plus twice of B. So you know that whenever any constant is multiplying with the matrix, that means that constant will get multiplied with each element inside the matrix. So 2 times -1 is 2, 2 times 0 is 2, 2 times 1 is 2, 2 times 2 is 4. Now what do we have to find? We have to find out A plus 2B first, and then we will find out A plus 2B whole transpose. So A plus 2B, simply the corresponding entries will get added. So -2 plus -2, that is -2 minus 2, that is -4. 1 plus 0, 1, 3 plus 2, 5, and 2 plus 4, 6. This is our A plus 2B. But we need to find out A plus 2B transpose. So simply you are going to change the columns to rows. So first column is -4, 5. That will become the first row. That is -4, 5 here. Second column will become the second row. That is 1 and 6 here. So this is the answer of the fourth question. Now let's go to the fifth one. I'll write down here. In the fifth one, for the matrices A and B, we need to verify AB. Here is the product. Okay. That also I've explained already in my previous videos. So yes, let's do this question. So we need to verify that A into B transpose is equal to B transpose A transpose, right? So yes, let's start with this. So on the LHS, we have A into B transpose. First, let's find out AB only. So what is A? We have the matrix given A, that is 1, -4, 3. And B, we have -1, 2, 1, right? Now to multiply the matrix, the very first thing that I personally advise, to all of you is write down the order of the matrix, okay? So this has how many rows? 3 rows. How many columns? 1 column. This is how many rows? Only 1 rows. How many columns? 3 columns, right? Okay. Now the resultant is going to be simply this by this. That means the resultant is going to be 3 by 3 matrix. Okay. So that is also giving you a confidence that, okay, you are getting a correct answer almost. So almost, but yes, perfectly. Okay, so now let's find out A into B. So how will you find out A into B? You have to take the first row and you have to multiply with the first column. So 1 times -1 is -1. Now you have to take the first row and second column. So 1 times 2 is 2. Now you have to take the first row and third column. So 1 times 1 is 1. Now you have to take the second row, first column. So -4 times -1 is 4. Now -4 times 2 is -8. Now -4 times 1 is -4. Now for this 3 times -1 is -3. Like all these, detailed explanation how to do the product of the matrices I've already explained. So here I'm going a little fast. So 3 times -1 is -3. 3 times 2 is 6. 3 times 1 is 3. This is our AB. But we need to find out AB transpose, right? As you can see on the LHS, we have this. So this is AB. Now, if you want to find out AB transpose, so let's write down here that AB transpose is simply going to be the first column will become first row. So -1, 4, -3. Second column will become second row. So 2, -8, 6. Third column will become the third row. So 1, -4, 3. This is our AB transpose. Now, we are done with the LHS. We have to find out the RHS now. That is B transpose A transpose, right? So it's like the product of B transpose and A transpose. For that, what are we going to do? We are going to write down the B transpose and A transpose. And for that, I'll just paste the question once again because it is a little difficult to go every time. So that's where I'm coming back. So we are just finding the RHS. On the RHS, we have B transpose multiplied by A transpose. So first, let's find out the value of B transpose. So what is going to be B transpose? Do not get confused. I'm talking about this B matrix. So B transpose is simply going to be the row will become column, right? So -1, 2, 1. This is B. Now what is A transpose? A transpose is simply going to be the column will become the row. So 1, -4, 3. Now, what do we have to do? We have to find out B transpose A transpose. Again, if you want, you can write down the order of the matrix. It is 3 rows and 1 column, and it is 1 row and 3 columns. So, of course, the resultant is going to be 3 by 3. So, it's again very simple. First, you can say row with the first column. So, -1 times 1 is -1. -1 times -4 is 4. Next, we have -1 times -1 times 3 is -3. The same way, 2 times 1 is 2. 2 times -4 is -8. 2 times 3 is 6. Next, we have 1 times 1 is 1. 1 times -4 is -4. And 1 times 3 is 3. Now, clearly, you can see that AB transpose, right? Okay. Yes. AB transpose, which is here, is same as B transpose A transpose. Hence, we can say we have proved. So, hence proved. Now, on that particular note, I also want to tell you that there is a very famous formula in matrix, and that is A times B transpose is equal to B transpose A transpose. This is also a formula. All right. So let me write down that. Okay. This is A transpose. A times B whole transpose is equal to B transpose A transpose. Remember, in the product of a matrix, the order is very important. A times B is not B times A. In matrix, multiplication is not commutative. Okay, so now we need to just prove for the fifth question, second sub question, that is this one. So I'll just take a picture of this and I'll solve it on the other side. Okay. Yes. So let's move to the other side and let's solve this as well. Okay, so we need to verify for this question as well. So quickly do this. First, we need to find out AB. Okay, so AB, that means, of course, you know how to multiply. 0 times 1 is 0, 0 times 5 is 0, 0 times 7 is 0. 1 times 1 is 1, 1 times 5 is 5, 1 times 7 is 7. Next, we have 2 times 1 is 2, 2 times 5 is 10, 2 times 7 is 14. This is our AB, but we have on the LHS, what do we have? We have AB transpose. That means we need to do the transpose of this. That means the first column will become first row. So 0, 1, 2. Second column will become second row, so 0, 5, 10. Third column will become third row, that means 0, 7, 14. This is what we got on the LHS. Now let's figure out what we will get on the RHS. So for that, let me change the color. So on the RHS, we have to find first B transpose. Okay, let's write down B transpose. So B transpose is going to be here, I'm writing it, is 157. Okay, and A transpose will become, I'm just writing it below, or I can just write down B transpose, A transpose for that. So A transpose, I'm supposed to write down transpose, it will become 0, 1, and 2. I'm just somehow not able to erase. It's like some issues. I'm just writing it, you know, like little weird. But anyway. So now if you do the product, it is simply 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2. Next is 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10. 7 times 0 is 0, 7 times 1 is 7, 7 times 2 is 14. And that is our RHS, and you can clearly see that LHS is equal to RHS verified or proved. Same thing. And we are done with the fifth question as well. Now it's time to go to the next question. So let's quickly go to the next question now. So many things. So fifth question, till fifth question we are done. Now it's time to go to the sixth question. And that is here. So in the sixth question, we have the matrices given. First is A equals given. We need to verify that A transpose times A is going to be I, right? So let's start with the first question. So you can see that A is already given, right? A transpose, you can see that we need to verify this. So that means on the LHS, we have A transpose A. So I'm just skipping one step and I'm writing it directly here. That what is the value of A transpose? Simply the first column will become the first row. So cos alpha, negative sin alpha. And this will become, the second column will become second row. So sin alpha, cos alpha, right? And then we have, of course, multiplied by the matrix, the original matrix A, and that is going to be as it is, cos alpha, sin alpha, minus sin alpha, cos alpha. And if you do the product of these two matrices, you are simply going to get, because I have already explained, so I'll go little fast here, cos square alpha plus sin square alpha. Make sure you watch the previous videos, which I've put in the description box. Everything will be clear how I'm multiplying all these matrices, okay? So cos square plus sin square alpha, and here we will get sin alpha, cos alpha, minus cos alpha, sin alpha. This is the second entry, or I can say A12. Next, we have sin alpha, cos alpha, if you do the product, and minus cos alpha, sin alpha. And the last entry is going to be simply sin square alpha plus cos square alpha. And the matrix is closed. Now, what do we need to do? We need to write down this properly. So, cos square alpha plus sin square alpha is 1. This is a very famous trigonometric identity, we all know. And this is sin alpha, cos alpha minus cos alpha, sin alpha. This is 0. This is 0 and this is 1. So, we are getting this, which is nothing but an identity matrix. And you can see we were supposed to prove this only. Hence, 2. So, we are done with the first question. It's time to go to the next question. And in this, again, we need to do the same thing. We have a different entries given this time, and we need to find, just prove that LHS is equal to RHS. So for that, what I'm going to do, because I know that, you have understood this particular question, so I have to erase it because I need to see the question as well to see, to make the solution. So I will erase it now. I think there is an issue in erasing, so I think I have to do it here only because I won't be able to erase. Oh, I think I'll be able to erase. Yes, perfect. Okay, so the first question is done. I'm doing the second question. If you have understood this, and if you want to keep the solution, I know I'm erasing it, you can take a screenshot. You can just go a little bit back in the video and you can take a screenshot. Okay. So now let's do the second question. In the second question, I'll be able to write it down now. So in the second question, we have the matrix A given, right? And we need to verify the same thing. A transpose times A is equal to I. Okay. Okay, I think I'm able to. Okay, so somehow I selected the color, the pen, and now let's start with the second one. So in the second question, we need to prove the same thing as we did in the first one. So for that, let's write down the LHS. On the LHS, we have A transpose A, right? So A transpose A. Now let's find out first A transpose. So A transpose is simply going to be the first column will become the first row, sin alpha minus cos alpha. And this will become, the second column will become the second row, that is cos alpha, sin alpha. That is our A transpose. And A, exactly the same matrix, and that is going to be sin alpha, cos alpha, and this will become minus cos alpha, sin alpha. Okay, so we simply have to do the product. Again, I'll just do it very quickly because I have already explained it. So if you multiply this, you will get sin alpha into sin alpha, that is, oh, So sine alpha times first row, first column. So sine alpha times sine alpha is sine square alpha. Plus minus cos alpha times minus cos alpha, that is plus cos square alpha. This is the first entry. Next is first row and second column. So sine alpha cos alpha minus cos alpha sin alpha. Next is the second row and the first column. So cos alpha into sin alpha. And then minus sin alpha cos alpha, because we have a minus sin alpha. And then the second row and the second column. So cos alpha into cos alpha is cos square alpha, plus sin alpha into sin alpha is sin square alpha, right? Now here I want to tell you, again, we are going to use that very famous trigonometric identity formula, and that is sin square theta plus cos square theta is 1. So 1, this is clearly 0, this is clearly 0, and this is 1. So we have this, and we can see that this is nothing but our identity matrix, and therefore 2. So we are done with the 6th question as well. Now again, I'll just wait for a while so that you can take a screenshot, because I will erase it and I will start the next solution over here only. Okay, so this, I just tried erasing little differently, but I think I did not success. Okay, so now let's erase this. Let's do exactly the same what I was doing before. Okay, the 7th question. In the 7th question, before we start, I want to explain something here. Check the card. Yeah. So show that the matrix is a symmetric matrix. Now, before I show that this matrix is a symmetric matrix, let me explain what is the meaning of symmetric matrix. Meaning of symmetric matrix is simply that A equals A transpose. If you are getting this condition that your matrix is a symmetric matrix, let's check. We have a A given. We will directly find out A transpose, right? Or you can do one thing, that let's write down first A, 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3, right? Now, what is the transpose of this? So if you find the transpose of this, so first column will become first row. So 1, negative 1, 5, right? 1, negative 1, 5, and then negative 1, 2, 1, and this is 5, 1, 3. What is this? Okay, I can just do one thing. This will be a little simple. That was A only, and this is A transpose. Now, can you not see that the matrix A is exactly same as matrix B? There is no difference in the entries. So it is exactly same. Therefore, or you can write down, since A equals A transpose, therefore A is a symmetric matrix. It's as simple as that. It was very, very simple. All right, so we are done with the question number 7. Now let's move to the question number 7.2. And that is, show that the matrix is a, please take, I hope you have taken the screenshot. If you have not, you can go back in the video and pause over there and take a screenshot. Let's do the question number 7, second question. And that is, show that the matrix A is a skew symmetric matrix. Let's understand what is a skew symmetric matrix. Symmetric matrix was simply A equals A transpose. Skew symmetric matrix is A equals negative A transpose. Okay, or you can say A transpose equals negative A, whatever you want to say. So let's check. So we have A given, right? So let's first find out A transpose directly. Okay, I'll directly check it from the question. I'll not repeat it. I'll not write down A again. So A transpose, you know that the first column will become first row. So 0, negative 1, 1. And this will, second column will become second row. So 1, 0, negative 1. And the third column will become the third row. So negative 1, 1, 0. This is our A transpose. Now what I'll do, I'll take negative sign common. If I take negative sign common, 0 has no sign, so it will be 0 only. From this minus 1, I have already taken minus outside, so it is 1. Here, there was no minus sign. It should be plus 1, right? So it has to be minus 1 only. There only it is going to be plus 1, because minus into minus is plus. Here again, -1, 0, no sign. Here minus is outside, so only 1. Here minus is outside, so only 1. Here +1, so I have to write on -1 and 0 as it is. Now, this is minus sign, and if you notice that this is nothing but your A, right? So you started with A transpose, that is why I said that, or you can write down A transpose equals negative A. So A transpose you started with, and you are ultimately reaching to negative sign and then the matrix A back. And since it is satisfying this condition, that is why it is a skew symmetric matrix. Okay, so we wanted to prove this. So skews, skew symmetric matrix. I was actually writing proof. I'll use the short form. Skew symmetric matrix proved. All right, so we are done with the 7th question. Now it's time to move to the 8th question. Okay, so for the 8th question, I'll erase this again and then we'll start. Again, it's very simple. Okay, you just need to follow the definition of a skew symmetric matrix. Nothing different than that. Okay, so you can see in question number 8, we have a matrix given 1, 5, 6, 7. We need to verify A plus A transpose is a symmetric matrix. Now imagine that A plus A transpose is one matrix, right? Now what is the definition of a symmetric matrix? That A is equal to A transpose. Here imagine that this is completely A. So this should be equal to the transpose of this, and if this condition will satisfy, that means our matrix, that means A plus A transpose is a symmetric matrix. So let's do that. We need to simply prove this. So for that, let's find out what is A plus A transpose. So A is 1, 5, 6, 7 plus A transpose. So if you do the A transpose, it will become 1, 5, 6, 7. And if you find the sum, it is going to be 1 plus 1, 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14. This is our A plus A transpose. We have found A plus A transpose. Now let's check. A plus A transpose is same as this or not. So if I do A plus A transpose transpose, that means this is A plus A transpose. And if I do the transpose of this, it is the first column will become first row, so 2, 11. The second column will become second row, that is 11, 14. And you can notice that we have got this matrix and this matrix exactly the same. What does it mean? It simply means A plus A transpose, that is our matrix, okay, because we wanted to prove this only as a symmetric matrix, is same as the transpose of this particular matrix. Therefore, it is a symmetric matrix. And we are done. All right, so this is a symmetric matrix, and next we have to prove A minus A transpose is a skew symmetric matrix. Again, please take a screenshot of this. I'll erase this and I'll start with the second question of the 8th one. So, yes. Now again, this is a proof question, so we will start with the LHS only. And let's get started. So in the second one, we need to prove that A minus A transpose is a skew symmetric matrix. What is the meaning of this? It means A minus A transpose, okay, here A minus A transpose should be equal to negative of A minus A transpose. That is the meaning, right? So let's find out the LHS. So LHS is A minus A transpose. So A is 1, 5, 6, 7 minus A transpose. If you do the transpose, it is 1, 5, 6, 7. And of course, if you subtract them, you will get 1 minus 1, 0, 5 minus 6, negative 1, 6 minus 5, 1, and 7 minus 7, 0. This is your LHS. On the RHS, we have first A minus A transpose, but negative of that. But we already have A minus A transpose, that is 0, negative 1, 1, 0. But we have a minus sign as well, so minus sign, right? So you can just start like this, that because we know that if we will be able to prove this, we are proving that our matrix is a skew symmetric matrix. So what is the meaning of this negative sign? That this negative sign will go inside and it will get multiplied with each of the entries. So 0 will become 0 only because 0 has no sign. Minus sign and minus 1 plus 1. Minus sign and 1 minus 1, and minus sign 0 is 0. And now you can see that this matrix is exactly, okay. 1 second. So we have A minus A transpose and negative of A minus A transpose, right? 1 second, let me check this. Okay, so we have got here RHS 0, 1, negative 1, 0. But this is our A minus A transpose. But what is the meaning of skew symmetric matrix? That this equals minus of this transpose. I forgot this transpose, right? So now we have this as minus of A minus A transpose. Now we have to do the transpose of this again, right? So the first column will become first row, that is 0 minus 1, and this will become 1, 0. Now you can see that this is exactly same as this. And that is why you can say LHS is equal to RHS, henceforth. If there is any doubt, again, I want to just pay your attention here that what is the meaning of skew symmetric matrix? That whatever matrix is there, negative of that whole matrix, right? I forgot the transpose sign. What I did here, I found out the LHS there. I found out the RHS, right? So it's negative of this, right? So negative of this is exactly same as this. So whatever answer I have got here, I wrote that. And then the transpose of that as well, which I had not done. So let me write down transpose, transpose. And in this step, I did the transpose. So I removed the transpose sign and hence proof. All right, so we are done with this question as well. Now let's move to the 9th question. Okay, so in the 9th question, let me erase this and then I'll explain what you have to do in the 9th one. Okay, so in the 9th question, we have to find half of A plus A transpose and half of A minus A transpose, right? Where A is given. So let's start. This is very simple, okay? So in the 9th one, we have A given. So first we will find out A transpose because A is already given. So what is the value of A transpose? It is simply going to be 0, negative A. I'm just writing it from here only, okay? The first column, first row. So 0, negative A, negative B, A, 0, negative C, B, C, 0. This is our A transpose. Now let's find out A plus A transpose, right? So what is A plus A transpose? Similarly, simply you have to add this and this. So if you add this, it will become 0, A minus A, 0, 0, 0, 0, 0, 0, 0, 0, right? This is our A plus A transpose. So even if you do half of A plus A transpose, like half will get multiplied with each entry, that is 0 only, so it is still going to be 0, 0. So we are basically getting a null matrix, right? Okay, now we are done with this. Now we have to find out half of A minus A transpose as well. But for that, we need to find out first A minus A transpose. So if you find out A minus A transpose, you can simply see that this is 0 and this is 0. So 0 minus 0 is 0. Next is A minus minus A. So it is simply going to be 2A. Next is going to be 2B. Next is going to be negative 2A, 0. This is 2C. Next is going to be negative 2B, next is going to be negative 2C, and next is going to be 0. But we need to find out half of this, right? So if I try to find out the half of this A minus A transpose, it is simply going to be half of A minus A transpose. Then each entries will get multiplied with half. So first is 0, so no problem, it's 0 only. This will become simply A, 2 will get cancelled. This is B, this is negative A, this is 0, this is C, this is negative B, this is negative C, and this is going to be 0. And you can notice that this is nothing but our matrix A only, right? Anyway, so we wanted to find out the value of half of A plus A transpose and half of A minus A transpose. So this is the answer for this, and this is the answer for the second one. All right, so now I hope you've taken the screenshot. Now let's start with the next question, and that is question number 10. Okay, so in question number 10, what do we have? Let's check the question. Okay. So in the 10th question, we have express the following matrices as the sum of the symmetric and the skew symmetric matrix. I know we've answered the question, so for that, let's go below because the question is right below. Oh. Yes, the question should be right below. Yes, and there we go. And this is our 10th question. Okay. So you can see here that we need to simply express the following matrices as the sum of the symmetric and a skew symmetric matrix, right? Now I want to tell you something here, that there is a formula to write down the matrix as a sum of a symmetric and a skew symmetric matrix. And that formula I'm going to write down here. And the formula is, you can write down a matrix as the sum of the symmetric and the skew symmetrics by using this formula, half of A plus A transpose plus half of A minus A transpose. This is the formula to write down any matrix as the sum of the symmetric and a skew symmetric matrix. Okay. Yes, though I said any matrix, but it should be a square matrix only. Okay. All right. Next is, what is the meaning of square matrix? The number of rows should be equal to the number of columns. Now let me tell you that this here is actually telling you the symmetric matrix, and this is actually the skew symmetric. And you can see that because this is symmetric, this is skew symmetric, so it of course is telling you that it is a sum of a symmetric and skew symmetric. So let's start with the first one. In the first one, we have A given. Let us just assume that this is A. So first we need to find out A transpose. So if you find out the A transpose, it is simply going to be 3, 1, 5, -1, right? Remember, we need to find out this. So I'm just accordingly doing it. So half of A plus A transpose. What is half of A plus A transpose? It is simply going to be first A plus A transpose we need to do. So if we do A plus A transpose, this is going to be half. I'm writing it here. And if you add this, 3 plus 3 is 6. Then we have again 6 here. Then we have here also 6. We have here also -2. And if you simplify this, it is going to be 3, 3, 3, -1. This is the answer of half of A plus A transpose. Now let's find out half of A minus A transpose. So if you do that, it is half. A minus A transpose is simply going to be 0, 4, -4, 0. And this is going to be 0 here, 2 here, -2 here, and 0 here, right? Now, what do we have to write down? We have to do the sum of this, right? Because we need to write down our matrix as the sum of the square and as sum of the symmetric and a skew symmetric matrix. So you can write down, therefore, the matrix that is given in the question 3, 5, 1, -1 as the sum of this, which is 3, 3, 3, -1 plus 0, 2, -2, 0, right? So we are done with the first one. Now let's start with the second one. Please take a screenshot, and I'm going to start with the second one now. So let's do the second one. We have a matrix A given 6, -2, 2, -2, 3, -1, 2, -1, 3. We only have to use the same formula. So let's first find out A transpose here. So what is going to be A transpose? You have understood how to find the A transpose. So again, I'll be a little fast here. And A transpose is simply going to be 6, -2, 2, -2, 3, -1. This is 2, -1, and okay, so here you can notice one thing. You can notice that once I found the transpose of this matrix, I'm getting A only. That means it is a symmetric matrix as well. So we got this. Now we know that the formula is A is equal to half of A plus A transpose plus half of A minus A transpose, right? But what we have got here, we have got that A transpose is equal to A. So wherever it is transpose, we can write down plus A plus half of A minus A transpose is A. Now this is going to be half. A plus A is 2A, and this is going to be half into A minus A is 0. Now clearly this will get cancelled, so we're getting A plus 0. So what is A plus 0? We are getting this matrix as the sum of this plus this, which is nothing but the matrix A, that is 6, -2, 2, -2, 3, -1, 2, -1, 3. Remember, in a matrix, 0 is nothing but a 0 matrix of the same order of the matrix given. So the 0, 0, 0, 0, 0, 0, and 0, 0, 0. So this is the answer for the second one, which is the sum of the symmetric and a skew symmetric matrix. All right, let's start with the third one. The third one, we have again, imagine this is the matrix A. So first, to use this formula, we need to find out A transpose. So if you find out A transpose, you will get 3, -2, -4, and the next entry is 3. The second column will become the second row. So 3, -2, -5. Next is -1, 1, and 2. This is your A transpose. So first, we will find out A plus A transpose, right? Or you can say half of A plus A transpose, right? So half, if you do A plus A transpose, if you add them, it was basically 6, 1, -5. I'm just adding the corresponding entries, 3 plus 3, 6, 3 minus 2, 1, like that. And next we will have 1, -4, -4. Next we have -5, -4, 4. And if you do the half of this, it is simply going to be 3 half -5 by 2. This is 1 by 2. This is -2, -2, -5 by 2. This will become -2, and this will become +2. Okay. And this, okay, this is nothing. This is our half of A plus A transpose. Now it's time to find out half of A minus A transpose, right? So if you find out half of A minus A transpose, it is half as it is. And let's start finding out A minus A transpose. So it is going to be 0, 5, -3. Remember how I'm doing? It's A minus A transpose. So 3 minus 3, 0. 3 minus -2, that is 5, like this. So 0, 0, 5, -3. Next is -5, 0, 6. And the next is -3, -6, 0. So therefore, we have got the answer of half of A plus A transpose and half of A minus, oh, okay, I need to multiply this half as well. So it is simply going to be half of A minus A transpose will be 0, 5 by 2, -3 by 2, -5 by 2, 0, 3, -3 by 2, -3, and 0. So this is the final answer. And the sum of this and this, you can see here. And the last, if you want, you can just write down that the matrix A, okay, I'm not writing it, equals the sum of this plus this. That is your final answer. Okay, let's do our last question of question number 10. So the fourth one, again, if I take this as a matrix A, I'll first find out A transpose. And it's very, very simple, just like the first one. So A transpose will become 1, -1, 5, 2. So what is A plus A transpose? A plus A transpose will simply become 2, 4, 4, 4. And if I try to find out A minus A transpose, it will become 0, 6, -6, 0. Now next is we have to write down A as the sum, like using this formula. So it is simply going to be half of this, which is 2, 4, 4, 4, and half of A minus A transpose, that is 0, 6, -6, 0. So you can simply write down that this is nothing but 1, 2, 2, 2, and this will become 0, 3, -3, 0. So this is the answer. If you want, you can write it on the left hand side, this A, the matrix given in the question. Okay, so we are done with the 10th question. Now it's time to move, or I can say do the last two questions, okay? So let's quickly do the last two questions, and both the questions are MCQs, right? So in the first question, we have a matrix. Okay, so it is saying choose the correct answer in the exercises 11 and 12. If A and B are symmetric matrices of the same order, then AB minus BA is a skew symmetric, symmetric, zero matrix, identity matrix. Okay. So let me tell you, I'm going to solve this particular question by taking an example. So for the 11th one, imagine I have a matrix given A. Okay. So A is given 1, 3, 3, 2. Okay. And I have a matrix given B, negative 1, 4, 4, 0. All right. So it is given that A and B are symmetric matrices, right? So that means if I just find out first what is the answer of AB, that means the product of A and B, it is simply going to be 1, negative 1 plus 12, that is 11. 1 times 4, 3 plus 0 is 0 only. So 3 times negative 1, negative 3 plus 8, that is 5. And then 12 plus 0 is 12. This is AB. And if I try to find out BA, what it is going to be, it is going to be, if I directly solve this, because you know how to do this multiplication of a matrix using, like by watching the first two videos, the answer of BA is simply going to be 11, 5, 4, 12. And if I do, because the question is AB minus BA, so AB minus BA, if I do it, I'll be getting 11 minus 11, 0. 4 minus 5 is negative. Yeah, 4 minus 5 is negative 1. And then 5 minus 4 is 1. 12 minus 12 is 0. Now, this is AB minus B, right? And if I just look at AB minus BA is this, and if I do the transpose of this, what I'll get? I will get the first row as the first column. That is simply going to be 0, right? And this will become 1. This is negative 1 and 0, right? Correct? And you can see that we have AB minus BA as this. And if I do the transpose of this, right, I am getting this answer. And if I take here the negative sign outside, right? If I take here the negative sign outside, I'm getting 0. This is negative 1. This is 1 and this is 0. That means I'm getting AB minus BA as negative of the transpose of this. That means it is satisfying the definition of a skew symmetric matrix. That is why this is the answer. Okay, the last question, and that is the 12th question. Let's do that as well. So we have A matrix given, we have given A plus A transposes I, we have to find the value of alpha. So if I do A plus A transpose, that means if I just write down here, okay, let me just go a little below, down. So A, okay, I can do one thing, I can erase this, and I can do the last question of today's video. So it is A, that is cos alpha minus sin alpha, cos alpha, that is our A, plus A transpose. If I do the transpose of this, it is simply going to be cos alpha, sin alpha, minus sin alpha, cos alpha. Okay, so it is given that the addition of this and this is going to be I, that means identity or matrix, that is 1, 1, 0, 0, 1. If I solve this part, it is going to be cos alpha plus cos alpha, that is 2 cos alpha. This is going to be minus sin alpha plus sin alpha, that is 0. Next is minus sin alpha plus sin alpha, 0. Cos alpha plus cos alpha, 2 cos alpha, right? Now you can see that we have two matrices, like they are equal to each other. And we know that if there are two equal matrices, then their corresponding orders are, like the corresponding entries are equal, right? So it simply implies that 2 cos alpha is going to be equal to 1. That means cos alpha is going to be half, And we know that for what value of cos the value is half, it is for cos 60, right? Now we know that there is a formula that cos theta equals cos alpha. If we have cos theta equals cos alpha, then theta equals alpha. So here, of course, alpha is going to be 60 degree. If you want to write down 60 degree in terms of pi's, it is simply going to be pi by 3. So therefore, the answer is, because you can see the options is in in the terms of pi's, it is going to be pi by 3. That is option B. And that is it. Thank you so much for watching this video. I know this video is super duper long, but yes, I hope you understood every single question. Thank you so much for watching my video till the end. Hoping to see you very soon with my next video.